Hi, in previous lecture I discussed data flow analysis. Let's discuss data flow analysis schema. We associate with every program point a data flow value that represent an abstraction of the set of all possible program set. For this program point, we are assigning a number before every statement and after every statement, that is called as a program point. So for every program point, we'll assign some data flow value. Let this is a statement. Before that one number will be 1, after that one number will be 2. So these are the program point for this statement. We donate the data flow value before and after each statement by in of s and out of s. Let it is a statement, and before that one program point is 1, after that one program point is 2. So this one is nothing, it is our in of this statement, in of s, and this 2 is our out of s. So before every statement there will be in of statement, and after every statement there will be out of statement. So it is our challenge to find value for every in and for every out of all statement s. There are two type of constraint. One is transfer function constraint and another is control flow constraint. Let's first discuss transfer function constraint. The data flow value before and after statement are considered by the semantic of the statement, that is called as a transfer function. Let a value equal to v, and after this statement b value will also be v. So the relationship between data flow value before and after assignment statement is known as transfer function. Before this statement and after this statement, what is the relation between data flow? That is called as a transfer function. Transfer function may propagate two ways. One is forward, another is backward. It may propagate forward along with the execution path, or it may flow backward of the execution path. So in forward flow problem, let the transfer function be fs of a statement s. Take the data flow value before the statement and produce a new data flow value after the statement. Let this is one statement s, and before there is in of s and after there is out of s. Then in forward flow problem, out of s take value from in of s. So out of s equal to fs in of s. In backward flow problem, the transfer function fs for statement s convert a data flow value after the statement to a new data flow value before the statement. Let this is a statement s, before there is in of s, and after there is out of s. So in backward flow problem, what it will do? It will take value from out of s. In of s will take value from out of s. In forward flow problem, out of s will take value from in of s, while in backward flow problem, in of s will take value from the out of s. We can write in of s equal to fs out of s. This is a backward and this is a forward. If out is taking data from in, that is a forward. If in is taking data from out, that is a backward. Next, control flow constraint. If a block B contains statement S1 to Sn in that order, then control flow value of Si is same as control flow value of Si plus 1. We can say in of Si plus 1 equal to out of Si. Suppose there are S1, S2, S3, three statements are given. 1, 2, 3, 4. These are the program point. Now for S1, in of S1 will be 1 while out of S1 will be 2. Then for S2, in of S2 will be 2 while out of S2 will be 3. Then for S3, in of S3 will be 3 while out of S3 will be 4. Let in of S2. What will be in of S2? It is 2, means that is same as out of S1. So in of Si plus 1 is same as out of Si. In of S2 is same as out of S1. In of S3 is same as out of S2. The set of definition reaching the leader statement of a basic block is the union of definition after the last statement of each of the predecessor block. Let this is one block. Before that there are some predecessor block. Predecessor means before that or prior to that, and successor means next. So there are some edges like this. Let this is block 1, this is block 2, then this is block 3. So what it is saying, the set of definition reaching the leader statement of basic block is the union of definition after the last statement of each of the predecessor block. So in for block 3 will be union of out of last statement of block 1, union out of last statement of block 2. This was all about statement. Let's do data flow schema on basic block. What will be output for a basic block? What will be input for a basic block? If S1 is the first statement of basic block, then in of block will be in of S1. Let this is one block, S1, S2, S3. There are three statement is given. Then in and out, and let this is block 2. So in of block 2 will be in of S1, while out of block 2 will be out of S3. That it is saying in of block will be in of first statement. If Sn is the last statement of the basic block, then out of block will be out of last statement. In forward flow problem, we can say out of B equal to FV in of B. FB is the transfer function of basic block. So out of block will be transfer function through in of block. Let this is one block, here in of block and here out of block. Then out of block will be transfer function of in of block. Let this is one block, and before that there are many predecessor. So what it is saying, in of this block will be union of predecessor of out of B. Let this is one predecessor, this is one predecessor. So it will be union of out of this block and out of this block. If there are edges like this, let this is block 3, this is block 1, then this is block 2. Then we can say in of B3 equal to out of B1 union out of B2. So this is the relation of block in forward flow problem. Let's discuss in backward flow problem. In backward flow problem, in of B equal to F of B out of B. Let this is one block, here is out of block, and before that block this is in of block. Now it is saying in of block will be FB out of block. Data transfer this way. So in of block will take data from out of block. Let this is one block and there are three block like this. Let this is block 1, this is block 2, this is block 3 and this is block 4. So out of B, here it is out and here in. So you can say out of block B1 equal to in of block B2 union in of block B3 union in of block B4. So out of B equal to union of its successor in. Successor means next block, predecessor means previous block. So it will take union of successor in. This is all about data flow schema for statement and for basic block. In next lecture, I will discuss reaching definition. After reaching definition, I will discuss live variable analysis. If this lecture is helpful for you, please like and subscribe. Thank you.